let's consider a few more examples of the chain rule. So we'll have example 10, y equals x squared times 2x minus 3 to the fourth. I'll have to use the product rule to get started here. So y prime will be equal to the derivative of the first function, in this case 2x, times the second function, 2x minus 3 to the fourth, plus the first function times the derivative of the second function, which by the chain rule would be 4 times 2x minus 3 cubed times the derivative of the inside, which is 2. I'm going to clean this up a little bit. So I'll leave the first part alone. It's 2x times 2x minus 3 to the fourth plus x squared times 4 is 4x squared times 2 is 8x squared times 2x minus 3 cubed. I'm going to clean this up a little bit further just because I can. Each of these terms has a 2x minus 3 cubed, so I'll bring that out front. And that will leave me with 2x times 2x minus 3 plus 8x squared. And I can clean this up a little bit more. 2x minus 3 cubed times, I'll have 2x times 2x, which is 4x squared, plus the 8x squared is there. Will give me 12x squared minus 6x. And I'm going to choose to stop there, even though this will factor. In fact, it does factor, so let me just take it one step further. I'll have 2x minus 3 cubed times 6x times 2x minus 1. Let's consider another example. Y equals x times 4 minus x squared. Well, to find the derivative, I'll start with the product rule. The derivative of the first is 1 times, I'll rewrite this as 4 minus x squared to the 1/2 plus the first function times the derivative of the second function, and by the chain rule I'll have 1/2 times 4 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. I'll clean this up just a bit. Y prime will be this 4 minus x squared to the 1/2 plus x times 1/2 is 1/2 x times negative 2x is negative x squared times 4 minus x squared to the negative 1/2. And if I clean this up just a little bit more, I'll have 4 minus x squared to the 1/2 minus x squared over 4 minus x squared to the 1/2. And again, how far you clean it up in one sense is a matter of preference, in another sense is a matter of usefulness and what the task at hand is. So in one sense this is correct. This is a little bit better just because it's cleaned up, and then some textbooks may take you to here because they've simplified it. They may even take it down to one fraction, which the context kind of determines how far you must simplify or should. Let's do example number 12. y equals 2x minus 1 over 2x plus 1 to the fifth. By the chain rule, the derivative of the whole thing will be 5 times 2x minus 1 over 2x plus 1 to the fourth. And then the derivative of the inside, I need to use the quotient rule. So the derivative of the numerator is 2 times the denominator minus the numerator times the derivative of the denominator, and this will all be over the denominator squared. So again, in one sense this is correct. In another sense we can try to simplify this. I'll simplify it a bit. So I've got 5 times 2x minus 1 over 2x plus 1 to the fourth times, numerator is going to end up being 4x plus 2 minus 4x plus 2, so it'll end up being 4 over 2x plus 1 squared. And we could clean this up even more if we wanted to. I'm going to choose to stop here. Again, context will determine everything. In this last set of examples, we're given these values for f of 2, f prime of 2, so on and so forth. And we'd like to find the derivative. We want to find the derivative at x equals 2. So in example 16, we want to know what the derivative of f of x times g of x at x equals 2. So this is just function notation, and I'm multiplying two functions together. So by the product rule, the derivative must be f prime of x times g of x plus f of x times g prime of x. And we're asked specifically at 2, so f prime of 2 times g of 2 plus f of 2 times g prime of 2. And we were given that f prime of 2 is negative 3, g of 2 is 3, f of 2, f prime of 2 is not negative 3, it is 6. F of 2, though, is negative 3, and g of 2, g prime of 2, is negative 2. So altogether this is 18 plus 6, or 24. So the derivative, in this case, of f of x times g of x at x equals 2 is 24. Example 17, f of x over g of x. And the derivative is just using the quotient rule. So we would have f prime of x. I'm just going to save a step here because we're looking at 2. So f prime of 2, g of 2, minus f of 2, g prime of 2, all over g of 2 squared. We're told all these values, so by substitution we would have 6 times 3 minus negative 3 times negative 2 all over 3 squared, and this just becomes 18 minus 6 over 9, which is 12/9 or 4/3. Two more examples, and then we can call it good. So we've got f of x cubed. And by the chain rule, this would be 3 times f of x squared times the derivative of the inside, which would be f prime of x. And since we're looking at 2, we would have 3. F of 2 is negative 3, and squared would be 9. And f prime of 2 is 6. And 27 times 6 is 162. Final, we've got f of g of x. And the function notation is odd here, but we need to take the derivative of the whole thing, so that would be f prime of g of x times the derivative of the inside, g prime of x. So we've got f prime of g of 2 times g prime of 2, because 2 is still where we're looking. G of 2 is 3, so we have f prime of 3 times g prime of 2 is negative 2, and f prime of 3 is 4. 4 times negative 2 is negative 8. So a lot of different examples involving the chain rule.